Well, hello everyone, and welcome to this Mobile World Live webinar that we're running as part of our themed week program for September. I'm Justin Springham, and I'm delighted to be your moderator for today's event. Today's webinar is brought to you with our partner Supermicro, and we'll examine why intelligent edge computing is so important to the next industrial revolution. We're going to hear about real-life edge-based use cases and how they are improving efficiency and reducing costs at manufacturing sites. Now, we'll be covering a lot of ground in this webinar. The aim is that in the next 45 minutes, you'll better understand the capabilities an edge computing platform needs to have today as well as in the future, as companies migrate to more open architectures and utilize AI and machine learning technologies. Plus, we'll be reviewing the benefits 5G will bring to smart manufacturing and its impact on supply chain management, asset tracking and logistics, and customer engagement. And we'll also discuss how new Open RAN technology could change the landscape. So let's kick things off with some introductions. I'm joined today by three expert guests. First up, we have Sylvia Kashish. Sylvia is Principal IoT Analyst at GSMA Intelligence. Welcome, Sylvia.
Pleasure to be here, Justin.
And we have two companies playing a major role in intelligent edge computing. From Supermicro, I'd like to introduce Jeff Sharp. Jeff is Supermicro's Director of 5G Edge Embedded Solutions. Welcome, Jeff.
Thank you, Justin. I'm looking forward to the session.
And joining Jeff and Sylvia is the CEO of edge cloud vendor NodeWeaver. Carlo De Fara, welcome to the webinar.
Thank you very much. It's a pleasure to be here with you all.
Great to have you all with us today. Just before I hand over to our speakers, I would like to encourage our audience to interact by posting comments and questions. We will have some time at the end of the presentation to address some of those questions. Simply submit a question in the box underneath the slides, and we will do our best to address it. Now, with that, I will hand over to Sylvia. Industrial IoT and smart manufacturing is a market that Sylvia has been covering for many years, and she's going to help put things into context. Over to you, Sylvia.
Thank you, Justin. So here at GSMA Intelligence, we see a short-term disruption due to COVID-19 pandemic in terms of number of IoT connections. The reason why? We see a replacement cycles lengthening on the consumer side, and we see project cancellations and postponements, more actually postponements than cancellations on the enterprise side. However, enterprise verticals will continue to grow in importance and will increase its overall share of connections to 54% by the end of forecast period, so by 2025. To support the move to digital transformation, we see and we expect smart manufacturing IoT connections to increase almost fifthfold between 2019 and 2025 to 1.5 billion, the fastest rate across all enterprise IoT verticals. So when we did a survey of enterprises at the end of last year, our survey showed that 65% of enterprises deployed IoT as part of digital transformation. But how is manufacturing faring in the face of pandemic? What we see is that the pandemic has showed some of the existing challenges and pain points for manufacturers, such as speed, resilience, and cost reduction, but also we see a greater and faster move to digital transformation. In the short term, factories had to adjust production levels to match demand through the use of digital tools such as cloud, IoT, and analytics. In the longer term, we see that the manufacturers will invest to drive supply chain visibility, increase automation, and also growing need for customization. However, what is very important to notice, and what is key to IoT is data is key to digital transformation, as devices and assets are being connected using multiple different technologies, including 4G and 5G. They collect data, run analytics in order to improve processes. And this is what we call the virtuous cycle of data. As more data is collected and analyzed, more benefits can be achieved by enterprises. Therefore, it is not surprising that the most important manufacturing IT solutions are data-driven. 50% of manufacturing players already use AI and machine learning to automate the processes, as our survey shows. And why is that? Enterprises are telling us that the way they measure success of their IT deployment is through the lens of cost saving, 69%, revenue generation, 60%, but also through compliance. And this is only going to grow due to COVID-19. And what is it that we see in terms of enterprises' needs to succeed? When we ask enterprises how important are certain features or capabilities for the IT deployment, the top three are the ones that you see in there. Reliability, very high chance of a successful transmission of information, 99% at the highest, followed by higher data speeds and edge computing. So processing a large amount of data on premise or at the edge, so close to device gateway, in order to improve efficiency. Private networks and network slicing are also seen as important by enterprises, but this chart really shows that enterprises really are ready for 5G. And when we look at what sort of coverage needs enterprises have, still the majority needs national coverage, so 60% say so, which is covering multiple regions or entire country, but increasingly 22% on average see a site-specific coverage being important. And that very much depends on vertical. So we see manufacturing being number 2, just behind utilities. So what does it mean when it comes to vendors? What we see is that custom-made products from one provider are very important to enterprises. The reason why is to make it very easy for enterprises to deploy solutions to address needs, to address the use cases that they have. And the reason to achieve that is to build partnerships and collaboration between different ecosystem players to enable just that. However, what we also see is that off-the-shelf products, at the moment, only at 14%, will increase due to COVID-19 and enterprises having to rationalize their spend. This is a very quick introduction, and I hope this provides a bit of context to the discussion that will follow. Now, Jeff, over to you.
Thank you, Sylvia. Actually, if we go back one slide, I'm going to go back to this one. I love this slide. There are 2 reasons why. One is, as you look at those top 3 boxes, custom-made product from one provider, supplement in-house capabilities, IoT components from several providers. If you narrow that down and you take it from a customer perspective, the key is they kind of want one throat to choke for a lot of the key hardware and software reuses. They want to do a lot of the stuff in-house. They want to do a lot of the capabilities in-house, but they know they need help. So they know that having cloud-based architectures and higher tech-based architectures, especially as they're migrating from old to new, is pretty major. But the key on this is the in-house, only 4% want this to only be owned by the in-house. So my takeaway from this slide, what Sylvia was saying, is it really kind of takes a village to make this happen. It takes a great amount of partners and, ensuring that I can reduce my risk on deploying this new great architecture for Industry 4.0. As I segue into our slides, one key thing I wanted to mention is during this market evolution that we're seeing, especially in 5G, it's happening now. So the hype is gone. We're seeing a lot of trials, a lot of real 5G deployments happening globally. So number one, it's working. Number two is they're not doing a rip and replace of 5G networks. They're adding to the existing networks themselves, but also it's forcing the operators to move into more of a software-defined area, a cloud-native area, pushing more to the edge for low-latency services. Another thing where this evolution is coming in is open architectures. So the operators, the service providers, the cable providers, they're really trying to deliver all of this great new technology on white box or gray box technologies using open software architectures, and also merging a lot of these common elements that are going to be reused throughout the network. And during this investment cycle, they are, looking at ROI. So how do I use this great new technology on speeds and feeds and the amount of products I can have? What's my return on investment? So they're going to provide more value-added services. And as they're deploying it, things are moving more to a virtual machine, to a containerized-based workloads, and you'll see more and more type micro data centers, which could be focused on an individual high workload product, a container, or maybe a small, containerized data center. One thing about this slide, so iScoop, I stumbled on this a few months ago, and what I love about this slide is if you think of the industrial revolution that we've seen since the late 1800s, early 1900s, on things like steam engines, certain components that were, it was great production analysis in these manufacturing, making manufacturing that's easier, especially using, steel and building trains and building boiler equipment, things that are based on iron-based production. And then, during World War II and then after World War II, at least here in the U.S., definitely a bigger production cycle on mass engines, turbines, mechanical gear, not just to supply, the armies and navies of World War II. But once World War II was completed, think of all the folks that are looking for jobs, manufacturing, areas that they can to build. So there was another wave of technology that was coming out, and with that technology, needed infrastructure. It needed more power. It needed more communications and so forth. And then in the 80s, I came from my original job was with Nortel Networks years ago, and walking through the manufacturing plant, I was just amazed at seeing these robots and all these cool things building these circuit packs and these PCBs going down the manufacturing line. Not in an autonomous factory. You still had people looking at the robots and managing the robots and sitting next to it. But now we're in this area of, almost 100% autonomous factories, factories that will still need people, but most of it's going to be relying on that edge-based gear, advanced robotics, autonomous robotics, high-speed connectivity, and also, things like computer vision, looking at something from a computer's view versus a human view. And there's a transition period going, a lot of factories, a lot of folks that we're talking to, every one of these stages, 1 through 3, they have those components in their manufacturing environment. And they're trying to transition to number 4 in a cost-effective manner. So how do we do that, especially within a 5G perspective? So it's really about software-defined networks and how we kind of build these networks both at the edge and also in a cloud environment. As Sylvan was saying, there was, different market verticals. Industry 4.0 is not just focused on production, logistics, oil and gas and mining capabilities, energy plants, solar, both renewable and existing, from coal-fired to nuclear, robotics, autonomous robotics. And those robots don't have to be a robot on the manufacturing floor. They could be an autonomous robot helping drive a car or a city bus or even a train system, public transportation. And all of these will be done in a a virtualized, containerized environment. It'll all be software defined using multiple applications on devices. And most of these also are very focused on vision techniques, AI, artificial intelligence techniques, which also incorporates learning, machine learning, and deep learning training capabilities. But the key to all this is that it has to be low latency in real time, meaning that we can't have these massive delays using, maybe a slow Wi-Fi network or a small, megabyte Ethernet connection. A lot of these have to be autonomous and real time in nature. And when I'm dealing with a distributed network of software-defined assets, those have to be secure, both in-house, at the edge, and also all the way to a cloud environment. But also the other key part of, especially autonomous robots is, workplace safety, reduction of accidents, repetition. A lot of these manufacturing positions, especially like meat packing and meat producing environments where there's a lot of repetition. So safety is a big part. Think of oil platforms and how dangerous it is to manage the drilling and pumping of oil. I love this slide, and I know it's busy if you look at it. There's a lot of words on here and a lot of graphics, but in essence, if you think of this new Industrial 4.0 model, you have two areas, one on the left, one on the right. One is the value. It's bringing this digital, bridging the digital attributes to the physical attributes. Looking at things like connecting the unconnected. I know we talk about that all the time, but things that have never been connected to a network can now be connected. A value chain organization through the entire process, from procurement to manufacturing to deployment to support. Now you have the ability to monitor that entire life cycle of the product. It's all data-driven. It's all analytical data to improve and manage your ROI, also to improve your future products as well. New capabilities. How do I, again, provide workplace safety? How do I deliver this product much faster? How do I use this data to improve my manufacturing and my quality? And how do I monetize? How do I actually monetize these investments and the innovation that I've been putting into to improve my, not just my revenues, but my earnings as well? And then on the delivery side, again, starting from the bottom, a lot of these components, these sensing devices are becoming more intelligent. You're now having, looking at pressure gauges, and you're looking at pressure sensors and temperature sensors, and, it's a whole gambit of type of sensing and sending, including intelligent cameras and dumb cameras and things that are looking at computer vision. But with that said, you have to look at all of these new mechanisms require power. So how do I manage power? How do I manage the assets and the sensor network that's going to go in? How do I control those? I've got a robotic arm that I'm using a very archaic system, and I want to transition that to a little bit better, faster, like a ROS2 environment, Robotic Operating System version 2. All the way to new services and collaboration. And the top one is key. As I said early, as Sylvia said too, it takes a village to do this. It takes a good ecosystem working together hand in hand to make this successful for the end customer. So putting all this together, from sensors to systems to connectivity and new systems, it looks like a lot, but you're also going from a transitional environment that you can take your time and do it. You can only pick one or two of these things, or you can actually go from a complete brownfield to a greenfield environment very quickly by instituting these base technologies. So from our standpoint here at Supermicro, along with our partners, as Sylvia was talking about, we're really focused on key areas. Energy, power, again, mining services, renewable energy with solar farms, wind farms, wave farms. Industrial IoT is also, if you also thought of Supermicro in the past, server-based technologies that go into, server farms, rack and stack environments. But we also supply that edge gear, those fanless products, those high environmentally conditioned environments that we have to put into that may not be controlled. It could be a very heat sensitive or cold sensitive environment that we can put our equipment. Retail space, with the whole COVID stuff that's going on, the separation of people, making sure people have their masks on, they're not have high temperature, social distancing, and also autonomous. Retail, just like manufacturing, is becoming more autonomous in nature. And then the other key part, which ties in a lot of the edge-based performance that we're doing, will include O-RAN. So, as I talked earlier, the operator service providers are focused on open architectures, and O-RAN is part of it. So moving the radio towers, the spectrum, the area that's actually delivering a lot of these high-speed services in O-RAN for virtual functions can be combined with those network services as well. Oil and gas production, outdoor transportation, how do we manage the logistics, the transportation of vehicles and trucks autonomously, how do we do that going forward? So very, very cool environment that we're heavily focused in these different market verticals. So from a Supermicro perspective, our strategy is edge to cloud. So we offer hardware that can go from that remote data center, that cloud environment, all the way to customer premise. And again, as I'll say, it has a lot to do with latency, that round-robin transport of messaging, along with the intelligence at the edge, at the customer premise. We offer hardware that could go with that radio head, that could do both O-RAN capabilities and IoT-based capabilities, all using the same workload, and actually providing better power savings, better management savings, all the different things that you're rolling up into what I kind of call a God box environment. We also offer network optimized hardware and fanless and fan-based products. Real quickly on this slide, what this talks about is defining edge and where edge is in that whole edge to cloud environment. So if you think of edge, usually you think of a sensor. Edge is definitely a sensor. These sensors are becoming more intelligent. Also the gateways that are handling all of those sensors and those devices, how I actually do data storage and manage those devices and take those analytics at the edge. The actual operations of applications and the edge of the network. All of these items require certain analytics, they require connectivity, they require some sort of intelligence. And our standpoint, working with our partners, is kind of doing this in as less hardware as possible. I know as a hardware manufacturer, it's kind of a hard pill to swallow, but we're really trying to provide value-added hardware and software services that are combining these into individual systems. And then as you move to the cloud, you have more data models, analytical models. Those are usually managed by your IT, and those operational elements and IT elements have to come together. And that's kind of the other key thing that we're seeing from a deployment perspective is enabling those operations. Also, from a workflow pattern, another thing that that seems to be resonating with our customers that we're doing is creating an environment that I can build these 7 patterns of AI technology, patterns, autonomous systems, predictive and analytical decisions, conversational, the Alexa of the world, voice recognition. We're trying to build these both hardware and software platforms as reused as a common platform between all of these different market verticals, whether it's a construction site, making sure that there's safety, or analytics on a manufacturing floor. The elements, the underlying elements are the same. You've got input from a sensor, a camera, I'm capturing it, I'm processing it, I'm training it as well, and I'm doing inferencing techniques, and then I'm visualizing and having a specific output. That output could be an analytical chart, or it could be a movement of a robotic arm, or moving a package off of a conveyor belt to somewhere else. So really kind of building that common workflow pattern using both our hardware and software. I want to introduce a great friend of mine and a partner of mine, Carla, who's the CEO of NodeWeaver. And if it wasn't for NodeWeaver, you know, in a lot of these cases, this is really that makes that glue happen with the migration to an edge-based environment. Carla, I'll hand it to you.
Yeah. Thank you so much for your introduction and for your kind words. Actually, the same applies to us. It will not be possible to run our platform without any hardware. So the key idea is that the edge is different. It's different because it's something that is actually a distributed collection of systems that needs to be scattered in tens of thousands of locations, most of them in areas where there is no local IT support, where there may be sourcing or provisioning difficulties, and they're with the environmental conditions that make it difficult to reuse traditional hardware. That's why a few years ago we started working on something different, because our idea is that it's difficult to fit something that was created for what is the protected environment of a data center and bring into the field. NodeWeaver as a platform is designed to execute any kind of workload. It can be traditional virtual machines, which are actually quite common in the industrial automation world, containers, Kubernetes application, or serverless applications, and make them autonomous. The key point is in taking advantage exactly of the same autonomous intelligence that has just been described in terms of AI, and put it to use inside to make this run anywhere. To make this possible, we made NodeWeaver modular. It's composed of a very large set of modules that automatically assemble themselves into what is the perfect configuration for your hardware and software. Through its autonomics, NodeWeaver is capable of managing itself. So it's able to compensate for software, hardware faults, or simply for changing conditions. For example, a new workload, a new AI task, or a different combination of incoming data sources. Some of these modules handle software-defined storage, networking, orchestrations. These are not simply buzzwords. They are actually things that serve a real need in the field. And I would like to give you just an idea of where we have been able to work along with the Supermicro in bringing this. One example is in the top left image is a company that develops power distribution and management systems for solar and wind farms in faraway locations. There is a very small gray box in the photo that contains two small embedded Supermicro servers. These handle all the customer applications, including network security and access, power management and alerts. Any hardware fault is automatically handled. Something that is quite important when the nearest IT technician is 2 days of travel away. And it does have, and it's probably more important, the ability to deploy new applications. They have the ability to improve the one already deployed anywhere in the world with a single command. The top right example is a deep learning enabled application in one of the world's largest automotive parts manufacturer. It's a high-speed thermal camera which is attached to the head of a robot welder. Along with an array of microphones, it processes in real time the video and audio and immediately detects a bad welding, allowing to immediately handle the bad part without losing time and having it go along with the rest of the manufacturing line. This is another example why you cannot simply use any kind of hardware. The servers are two very small systems that are placed on a shelf just on the side of the welder. So we need to have systems that are able to withstand dust, vibration, and high temperature. The bottom left one is another nice example. Is a major city in South America which uses NodeWeaver to receive video feeds from security cameras. And it uses AI to identify critical situations to help the law enforcement forces to immediately pinpoint areas that need attention. last but not least, the bottom right one is a major U.S. manufacturer, auto manufacturer, which is using a standard motherboard. It's just a custom enclosure. This is used to have a small box, a transportable box, which is able to withstand vibration and, let's say, damages. And it's used to translate and export data from autonomous cars in the various self-driving experiments that are happening in several major U.S. cities. All these examples show how important it is to be able the flexibility to run anything, no matter what application it is, anywhere, and to give this hardware and software combination to anyone without turning the operator into an IT expert. As we talk about deep learning and artificial intelligence, the first thing that we should focus on is using this incredible capability to learn and autonomously act to make the hardware and software better, removing yet another useless and difficult task from people on the field anywhere in the world. Jeff, would you like to take from here?
Yeah, thank you, Carlo. And one key thing that the feedback that we're hearing from a lot of our customers in this new world that we're living in Industrial 4.0 with both Supermicro and NodeWeaver is that it's working. And, they're looking at, that welding machine use case that he talked about. A great value point was our ability to deliver that very, very quickly in a heterogeneous system. These are AI computer vision systems. They have heavy workloads. They want to connect as many welding machines as they possibly can, but they also want those devices to be self-healing, self-managing, containerized services and applications that are not just moving that welding robot arm, but doing preventative maintenance, doing maintenance and management of the assemblies that are going on. So using those type of use cases, it's really, really resonating with the customer on a few things. One is the NodeWeaver self-healing, self-managing ability to manage from a middleware perspective the containers and virtual machines at the edge, because a lot of times these things, are very difficult to manage because of the location. And also Supermicro's ability to deliver the breadth and depth of our hardware capabilities with hardware, software, different types of functions and different types of environments. Next to a welding machine can get very, very hot with sparks and everything flying, or sitting in the back of a car that's doing self-driving. So that seems to be resonating. So the key things around as we leave this presentation is the market is converting. 5G is happening. We know that. It's also combining a lot of elements within the network as one. We know the system architecture and the technologies are moving towards the edge, but you also need that cloud environment to do training and learning techniques for your computer vision. We also know that a lot of existing brownfield deployments of manufacturing and other market verticals in this industry 4.0 are transitioning to a virtual machine container, and also need to be trained for these newer techniques. For us, working with companies like NodeWeaver, and other companies like SAS, we provide this low risk because we know it works on our hardware. We know we can deliver it quickly. So that risk and the agility that we can provide with the amount of products that we have definitely is helping all of us. And also being part of open architectures, ORAN, IIC, the Industrial Internet Consortium, OPATH, others, provides us a vision and a view into the future, so we can prepare not just our great hardware, but also working very closely with our software partners like NodeWeaver. And you can't do it with just one type of system. We know that every customer, every project, every deployment has certain needs of architecture, whether it's low-end or high-end CPUs, GPUs, OpenVINO, Movidius, all the different assets that are out there. We have the ability to combine within our systems. and we're a global company, that we can support multiple countries, because we know these areas are, no longer in one central country. They're global in nature. So I'll leave it there, and I guess we'll go into the question and answer, but I definitely want to thank Carlo and the GSMA staff for a great webinar.
Yeah, thank you, Jeff. That was great. So we have got some time now for questions. We've received some good comments. There is still time to ask a question. So if you would like to ask a question or make a comment, you can use the box underneath the slide presentation, and we'll do our best to cover it. So we're going to kick off with a question that I think I'm going to come to Jeff with this one first. One of our viewers asks, what are the biggest customer concerns you've seen in your engagements to migrate from legacy solutions to more intelligent AI-driven systems at the edge? So Jeff, what's keeping customers up at night? What are their biggest worries?
So number one, it's the amount of data that's out there that they can tap into to move into an AI world. How do I train my solution to do better using AI-based technologies? And also you're dealing with operational directors and managers and personnel, and you're also combining the information systems, the IT guys as well, for the learning. So how do I combine all that? There's so many, different training techniques, inferencing techniques. How do I deal with that? How many cameras can I attach to one device? It's the actual moving from a brownfield environment to a more automated AI-based system. And how we're trying to resolve that is kind of working directly with that customer, understanding where they want to go, utilizing our engineering staff to help with the hardware-based architectures. What is the right hardware? Is it an Atom? Is it a core-based module? Is it a Xeon? What kind of OpenVINO characteristics or GPU characteristics that's required? So we assist the customer on that, and then we pull in, definitely like a NodeWeaver to come in and help that transition part of taking maybe a really old-based application, maybe it's running on a PC, and virtualizing it and putting it in an environment that works well of where they want to move to. So it's really that AI training and then inferencing and how it all works together, and just guiding them through that path. And actually, we're trying. What's really resonating is we're all trying to work as partners, not just suppliers and a master-slave type of environment. We definitely understand what their needs are, what their ROI needs are, and we work around those requirements along with our ecosystem partners. And again, it takes a village.
Yes, I'm going to jump to another question. You ended talking about a village there, Jeff. David from Druid Software, he said, he made a point that obviously, Jeff, you noted that Sylvia's last slide implied that it does take a village to deliver industrial 5G edge. So who do the panelists believe will be the village chiefs? Who's going to be the village chief? Is that the telcos, system integrators, or new entrants? Maybe, Jeff, you touch on that first, and we'll ask for Carlo's input as well. Who's the village chief?
So I'll give you two examples. So I'll give you two examples. One, smart cities. So smart cities, if you think of a smart city, you have the local municipality, you have the county, you have the city council, the county council, you also have Department of Transportation, you have the power companies, and the list goes on and on and on. So really, who is the right integrator, or who is that chief that makes the decisions and all that? For me, I think that's the operators. The operators have that infrastructure, the connectivity, and the means, and of course the right-of-ways to have the fiber or the wireless solutions. They're the right company to be that chief architect that we can work into, and also make suggestions on the type of hardware and software that can be vital to all of those different municipalities and all other owners. From a manufacturing perspective, to me, it's the operational guy, the OT officer that's driving the old technology to the new technology. And that's where some of your heavy lifting is coming into play, because now you're using more computer vision techniques, more inferencing at the edge techniques, and where you place that hardware and sensors. To me, they're the ones that are kind of driving the overall solution, working internally with their IT, and also, the connectivity piece. Are they working with a 5G or LTE provider, maybe a CBRS or private LTE type provider, or their internal communications? Carla, you want to add something?
Yeah, it's really a village, especially because 5G is different in many ways compared to 4G. It is much more software driven. It is there are lots of open implementations that are designed to facilitate adoption. It's possible to create 5G compatible implementations out of a few of the protocols, so you can adopt 5G in a gradual way. And this is helping in for those companies that are feeling that the cost of adoption is too high. They can adopt one piece at a time, and they can adopt new open infrastructure that can be software upgraded later on. So the investment is not so significant. It's true that the operators are driving this because they are creating the basic capacity. But what we see from many customers is that they are also employing it from the bottom. So it is becoming some sort of a grassroots implementation, piecemeal, one functionality here, one there, mostly driven by real use cases, especially, as Jeff correctly said, by the OT guys.
And there's also another element too, as we're working with different analytical companies and, at the higher level of applications, where we see another key owner is the integration companies. I think IoT in general provides great opportunities for companies to take, a Supermicro hardware, a NodeWeaver middleware system, maybe a analytical computer vision-based system from SAS or whomever, and putting all that together and managing and supporting it globally. Those integrators are also acting as a key role. But in the 5G space specifically, that key integration activity is coming from the carriers. They're really acting as that managed service provider for these really cool technologies that are coming out.
Thanks, gents. I thought we might get a question on Open RAN. Jeff, obviously you touched on this during the webinar, but Victor from Huawei has asked, maybe just give a little bit more detail. He says, how will Open RAN technology play a role towards edge computing for manufacturing use cases?
So I think a few key things, at least from our standpoint from ORAN, we're supplying that edge DU component for eCPRI capabilities and also the connectivity into the CU piece that's managing multiple DUs, also the RIC. So if you think of 5G deploying more and more pico cell sites, micro cell sites, including macro cell sites, but there will be a tremendous amount of smaller cell sites going out. That ORAN capability will offer that open-based architecture at that radio side. For us, it's deploying, both hardware acceleration and x86-based technologies, working very closely, again, a village, working very closely with the ORAN software providers, going through trials and testing. But because these elements, the RAN itself will be located very close to these manufacturing areas, you can utilize these boxes. Our box for this one is, could be an outdoor IP65 waterproof server that could be mounted on the side of a building, on top of the building, on the radio tower itself, can not just provide ORAN services, but other capabilities that is provided in that small area that cell site connects to, using those 5G services. So not just providing a network element function, for ORAN, let's say DU-based capabilities, eCPRI-based capabilities, but also providing services to the surrounding areas, whether it's a retail store, whether it's a manufacturing area, a fire station, or even traffic lights, that's being supplied by that 5G-based infrastructure. Also, it opens up more and more open-based architectures at that radio site as well. You're looking at different, communities, Linux Foundation, Acrano, Intel's supporting Smart Edge for Mac. All of these different types of open arrangements will start combining some of those elements into one. So we're excited about that, and moving to this white box environment is pretty great, especially at the Pico and micro cell sites.
Thanks, Jeff. We have a question about devices specifically. A gentleman called Bent Olson asks, for smart industry, will there be IoT devices or embedded 5G devices? Which are more likely to prove the most popular, Jeff? IoT devices or embedded 5G devices, or is it going to be a mix of both?
I think it's going to be a mix. If you think of a really great example, again, is let's use retail as an example. So one of our real life use cases is around inventory systems, robots that are going up and down the aisles of brick and mortar stores doing inventory control real time, doing this 24/7, 365. That's an embedded component that's built into that robot with connectivity either through Wi-Fi or 5G, or when it goes back, just like a Roomba, a vacuum cleaner, once it attaches back to its cradle for charging, then it can connect to the network and upload all the inventory control. However, where we're seeing like manufacturing, where we're seeing other different components, whether it's a wireless component or what, it's usually, white box, high-end, but low power consuming boxes. These are standard products that are placed there truly at the edge, connecting to sensors and cameras. And a lot of those devices have to have the capabilities to run, higher wattage CPUs and GPUs because they're trying to combine as much as possible. From an embedded space, the embedded boards and motherboards we also manufacture, we also provide. So we see that kind of as being a mixed bag.
Thanks, Jeff. We've got time for one more question, and I'll direct this one at Carlo, if I may, and perhaps if Sylvia has any other thoughts. We have a question from one of our viewers saying, obviously there's lots of development around 5G, and we're about 18 months or 2 years into commercial 5G networks. But one of our viewers asks, how necessary is it for enterprises to move to 5G in order to make the most of smart manufacturing use cases? And is there, in fact, any reluctance to actually move away from 4G technology? Carlo, any comment on that, please?
Well, the companies adopt technologies either because they are forced to, because the existing technologies are not able to sustain their business anymore, or because they bring a significant advantage. When we talk about the migration to 5G, what we are actually talking is about the idea of moving from specialized hardware devices and specialized systems to a completely different architecture, which is entirely software-based. 5G is a lot of things. It's, of course, new access control mechanisms, it's new encodings, it's lots of technical details, but the key concept behind it is the idea that you end up with something which is a modular set of protocols and software technologies that basically can be run on a wide range of systems. So what we are seeing is that many companies that are starting to look at moving the entirety of their infrastructure technologies towards a software-defined model. And 5G is currently the only open, multiple-sourced and commercially available implementation of this kind of software-defined infrastructure. So they're going there because it's actually giving them the ability and flexibility that they need for what is actually an unprecedented period of time, because we are seeing in our customers an incredibly growth in the number of devices, of sensors, and the fact that these sensors are actually producing data at an unprecedented data rate. So they need to move, and 5G is there for exactly in the right place and the right moment.
Sure. If I just can quickly add is what we're dealing with in manufacturing settings, very long device life cycles. So not many of the deployments actually greenfield. Most of them are brownfield. So it is really need for technology that can easily work with others. And what we also see is the new services and applications that come through, they really need the lower latency and they need the bandwidth that 5G brings in. So there is definitely quite a lot of excitement at the moment. There is lots of testing going on, both by operators and then quite a lot of enterprises. And 5G is going to deploy it in different ways, right? We're talking about private networks, we're talking public networks, but in general, there is a need for connecting more devices because not that many have been connected thus far, and doing it in a cost-efficient way.
Thank you, Sylvia, and thank you, Jeff and Carlo too. Unfortunately, we are running out of time, so I think we'll use that as a good place to wrap up. We've had a great presentation. We've had some good interaction with our viewers too. We did receive a good number of questions. If we weren't able to get to cover some of your questions, don't worry, our speakers have your details and we can follow up where possible after the event. We did also have a few questions about availability of slides and whether the webinar would be available on demand, and the answer to that is yes, we will be able to make a full replay available within the next 24 hours, and that will be available on the Mobile World Live website. So with that, I'd like to thank again our speakers, Sylvia, Jeff and Carlo, and of course thanks to our audience for taking part, and we'll see you all again very soon. Thank you. Thanks everyone, and goodbye.
Thank you.
Thank you.
Thank you.
Thank you.